Well, alrighty, my friends. Today we're going to go about as far down the rabbit hole as you can go on this thing. So what we're going to do today is we're going to make cubes. And the thing that you need to know, my fellow wizards, is that once you get to this point, you're going to have to throw some of your hard and fast sort of rules and understandings out the window a little bit. And that's okay, because if you've made it this far, then you're pretty smart and you're willing to deal with a little bit of ambiguity. Okay, but let's start this way. Just as you know, a rectangle is not a square. They are two very different things. A square is a determined measured object, whereas a rectangle could be anything. Same thing with a box. A box is just any old shape that you want it to be, whereas a cube is a measured thing. When we make cubes today, they're going to be close, but who's to say if they are absolutely perfect? Because, once again, we're taking this crazy three-dimensional world that we live in, and we're trying to flatten it out to a two-dimensional space. But I think we can get pretty close. Okay, enough of that. So, as we work today, I'll be using this diagram right here a lot. So this is a square, measured square, and I'd like to refer to this as being straight on or straightforward, something to that nature, right? Um, and it's just a square like you'd expect to see a square. Okay, so this is the exact same square, but it is put at what I would refer to as a right angle. I refer to it as a right angle because if you were here, you have one angle going off to a 45, another at a 45, which adds up to 90 degrees, so a right angle. Okay, and then we'll also be working with odd angles. So if this is a right angle, this is a square that's just turned any old which way. And trust me, when I drew this, it was totally random. Okay, but that's where we are, and we're going to use those, like I say, to make sure that our cubes are pretty darn close to being right. Okay, well, let's run through this rather methodically. Okay, so our first example here would be a right-angled cube right in the center of everything, right in the center of your horizon line, everything in your picture plane, because that's going to be the most straightforward. And this is the one that I'll probably, walk you through the most. So let's see what happens, right? All right, so if you were to look in the center here, and all these drawings are going to have this, you will see here is my square. So if we turn this square, we will get a right angle. So let me draw out the right angle. So there you see we have a right angle right there. Okay. Now let's make a three-dimensional cube. So here's what you'd want to do. Since this is a right angle, it's just going to my vanishing points right here. So the geometric vanishing points. And I'm going to line it up with the edge of a square right here. Because if you were to rotate a square in space, okay, so now let's turn this square into a rotated cube. As I turn the cube, you'll see that at some point we have the same width right here, or the same height, right? So as I turn it, some of it is going to be in front and some of it's going to be in back, but part of it, there's some axial point right here that is going to be the exact same where it was when it was this way. Okay, well that's real life. Let's take a look and see what it looks like on paper. So if I've got that original square right here, right, And if I were to take and go back to my vanishing points here and here, just my regular old 2-point right angle geometric vanishing points, right? Then where I'd line it up with is, of course, the point, but also the corner of the square itself. If this is a measured cube, and of course bring it to the middle. Okay, so as we draw the line back, easy enough, right? And it's hitting the edge of our square right here. But how far back does it go exactly? Well, let's find out. We started with this one because it's, the easiest and straightforward, and pretty much a review of what we've done before. So right here, got my leading edge. Okay, that's fine. And we'll take it from the corner all the way up and actually up to this point right here. And that will give you my measured cubes full distance out. Let me show you. So why this point right up here? Well, if you'll remember from previous videos, if I was to go from the center to the vanishing point and then measure up, well, you would think that that would be it, right? Would make sense. But you would get something that was much flatter. It wouldn't go along and hit these edges right here. Okay. Instead, if you took the diagonal of that, you get a point right here, right? That would be your length. Now, watch this. If you went up that diagonal, like I said, look at this. It happened to intersect right here. It was like I was saying before, there's something almost magical about the geometry of this circle. All right, so I can do this to both sides. So up to this point up here. I wouldn't have to do it to both sides. I'm just sort of proving a point. And, all right, Mr. Coon, that looks pretty good. It does look a lot like a real cube, as you see, right? Those proportions look pretty good. And here's what's more, is with this cube, like most of the other ones, we can measure, we can see, because, what I'm trying to show you here is really to take a lot of the guesswork out of it. I hope to do one last video at the end where we talk about intuition, because that's what this really comes down to in the end. But, okay, but let's look at this. If you had this square right here at a right angle, okay, here's one side, here's the middle, here's that. That's how wide it is across, right? And we see this, it is not quite as wide as it would be across, right? And which is perfect because it's in perspective, because these are getting smaller as they're going away. So you can see by the measurements, yeah, that's a pretty darn perfect cube. And a cube is a wonderful thing because with a cube, you can make a cylinder, right? It's a basic building block. You can measure things off. You have a unit of measurement. Okay, so we've got a pretty darn perfect cube this way, but it was totally in the middle. Can we move this around, right? Because that's the real thing about the perspective. Does it warp as we get to different areas on the picture plane? Well, let's make one that is also right angle, right in the center, but down below the horizon and see what happens with that. Okay, so you'll see I've got my square drawn once again. That's my same measured square. And if I go to the edge of the square here and off to the vanishing point, and the edge of the square here off to the vanishing point, same thing on the other side. Okay, easy enough. So we've got that point right here. So don't worry, I won't keep repeating myself, but we've got a square And so at some point, as you turn it, right, then it is going to be as wide as that square at some point, right? And then some of it's going to be in front and getting wider, and some of it's going to be back and getting smaller, but it will meet at that square at some point if we're making really measured cubes, right? And we're trying to really be accurate right now. Okay, great, Mr. Kuhn. But how do we find how far back it goes this way and this way, right? That's the important thing. Well, just like before, we can take and we can go back to this point up here, and it seems to work out pretty darn well. It doesn't distort it very much, and we still end up with a pretty good cube. Let's see what it looks like. Okay, let's take a look. As you can see, we've gone from the corner right here, measured it out to the same vanishing point right up here, and yes, we've got a good cube, and as we can see, it measures very well, just like the last one. Pretty much the same, actually, where we've got it being just slightly smaller than our measured square right here, as you can see. Okay, cool, right? Well, so it worked when it was on the horizon line, and it worked below the horizon line. We still have it in the center. Can we move it off center? How would we deal with that? Alrighty. This one gets just a little bit weird. First, I'll draw the square that we're measuring it all off of. So we've got our square, and just like before, I'm going to take and run that down to the vanishing points. Okay, so just as before, we've got it going back this way and this way, with some in front and some behind. But exactly how far do we take the edges here and here? Alright. So as we go this way with it, remember, if we were to rotate this cube starting here and rotating it, it would become flat by the time it came over here, right? So this angle here does not change, not one bit. Okay, but this angle here actually does. Let me show you that in just a second. So first this side. So far so good, because this area actually should be getting narrower as it rotates this way, as we see on the real block. That's taking up less space, like that. Okay, cool. So, but what about the other side over here? Well, what I've discovered is that you would have to move it a little bit. So if you had this over here, then you have to move it over the same distance as what you had from the center, kind of. What I mean is this, is that we're going to have to change our other point just a little bit. So on this one, if we were to line this corner up here with our regular vanishing point, it's going to look pretty good because this is where it's at. So, hey, Mr. Kuhn, no problem. Why don't I just do that? Why don't I leave it alone? What are you talking about moving this over? Well, because you'll see in the next example that as you move it, a distortion is going to start to grow a little bit. So what we've got to do is we've got to take the measurement from the distance, right, to the leading edge here and measure that. And bring it over. But unfortunately, you don't bring it over from there. You bring it over down here. Weird, right? Why is that the thing that works? Don't ask me. I don't know. My mind just cannot wrap around spheres because really that's what we're dealing with. We're dealing with three-dimensionality and spheres and trying to somehow or another relate that in a very precise way to a two-dimensional surface. But you'll see that when I put that there, it works out and it moves it over just a skosh from where it was. Let's see what it looks like. So once again, we end up with a cube that's really pretty darn accurate. If we look at here, what's happening is that this edge is getting smaller, this edge is getting larger, but as you'll see here, not too large, right? Because it's got to be smaller than this, but it's got to be larger than this for it to be accurate. And well, it works out pretty darn good. Can we move that one below the horizon line? Well, let's see. Starting with a measured square, we're going to go back to our vanishing points. For this side here, I'm going to go back to that same vanishing point as before. For this side here, I'm going to go ahead and take this back to the same vanishing point that I had derived when I made this one. Remember, this was from going from the center to the leading edge. And I got this measurement here, and I ran it across this point right here. Okay, so where these intersect these lines here, that should be my cube. Let's see what happens. Well, did it work out? It looks pretty right, but let's see. Let's measure it. So I'll take it up here and compare it to this. Is this side thinner than this one? Yes. Thicker than this one? Yes. But is it too thick? No. So, and is the overall width, right, greater than this? No. So we see that it's all worked out pretty good. So that is a pretty darn good measured square. Okay. So let's see what happens when we take it further off center. So here's a much more extreme angle. We start once again with our square, and let's see, we're going to take it back to our vanishing points, right along the edge right here. Remember to intersect that edge, and let's see what happens. Okay, pretty good. But on this edge, since we're coming this way this time, I'm going to use this vanishing point just the way I had done it on the other side. And my thinking is because I'm rotating it this way, right? So this vanishing point should stay the same. Let's see what happens. So we're looking pretty good. This side of my cube got much narrower, right, as it would if we were turning something in space. Getting a lot narrower. Now let's see about this side here of our cube. So if you'll remember from the example I was showing you just not too long ago, that we had to create this distance. But when I lined things up, and I went to this vanishing point, it's like, well, but that seems right, and maybe it would have, been close enough. Would have seemed fine. But when we carry it to more extremes, let's see what happens. So if we were to take and line this corner up with this corresponding vanishing point over here, just the opposite of what we were doing on the other side, let's see, where would it intersect? Well, it would intersect way out here. And that can't be right, because if it intersected way out here, and if we were to draw that line, then we would soon see, when we checked it, that it had a lot of problems. Well, does it turn this way? This was fine, right? Is it wider than this? Yes. Is it greater than the overall length? No, it's a little bit shorter, so well, maybe it's okay. But when we check it here, we see, oh no, That's not right at all, right? Because this length cannot ever be greater than this one. Okay, so remember that thing about moving it over the distance from the center. Let's see what happens. So if I was to measure this here, say, okay, that's how long that is. And if I was to move it over here, remember we're moving it on this one for some crazy reason. Don't even ask me why it's not up here, but it's not. Okay. And then we were to go ahead and line that up here to here, right? We would get this mark right here. All right. Well, let's go with it and draw it down, see what happens. Not only do we see that it looks a lot more right, but it measures a lot more right. So here, this edge is turning pretty darn flat this way, right? But not all the way, so it's just a little bit smaller than it would be if it was flat. And the overall length is also decreased a lot because when we have this guy here, he's turning a lot, right? So it's a lot closer to this than it is to this at this point. So it becomes a lot narrower. All right, well, cool. You know, and I like informing this with reality because in the end, remember, that's what this is all about. It's not just about doing these little perspective puzzles, which are actually kind of interesting to me, but it's about gaining a perception that's going to help us become better artists, more accurate artists, if that's what we choose, right? Okay, well, enough pontificating from me. Let's see, will it work as we go down below the horizon line? Okay. Okay, as always, I'm just going to start with this measured square right here and take that back to the vanishing points. Okay, so this is looking pretty good. You know, we've just taken it to our vanishing points here, and we've taken it up to the vanishing point here. And so next we should be able to just take it to the vanishing point here, just like we did with this one here. And the thing is that if we do this all right, then this should be the same width right here, okay? Because basically you're just taking this and you're just bringing it down. You're not moving it over at all. So let's see what happens. Uh-oh. I can see already we've got a problem. If I went to the point right here, it would give me a mark right here. And that would just be crazy because as you can see, what it would do is, remember on this point here, we had to have some of our block coming forward and we had to have some of our block going back, right? You know, otherwise it's not really correct. So we can see here, it's only going forward. So we haven't done something right. And if we were to make it that narrow, it'd be far skinnier than this one. Well, remember, I told you there wasn't going to be any hard and fast rules. You're just going to have to be finding relationships. Okay, so this is pretty crazy. So, you know, we know about how it should be, right? We can use our own sort of judgments if we didn't have something like this to look at it and say, like, wait a minute, no, that's not right, right? So in finding the relationship, here's what we can do. We can say, okay, where can we go on here that it's going to be looking about right? And by my judgment call, that ends up about here, right? Because we've gone back just a little bit, because remember, we're here on our little cube, right? And we're going, turning it just a little bit back, right? So it should be just a little bit back. So where's the relationship? And when I looked at this distance here, I did not find one, right? Because here I am going along here, thinking, okay, it should be somewhere in here. And here's my measured, oh, where was it? Here's my measured distance right here. Okay, do we have something? Ah, that's not right. That's not right. Down here, well, what does that have to do with anything, right? So nothing seems to be working. Ah, check this out. Okay, so if on the other hand, we took this here on this other side, and we took a measurement that said, okay, here is how far the center is, or our leading edge, I should say, from the edge over here, do we get a relationship then? And lo and behold, we do, right? We can run it along this way, and here, no, here, no, here, ah. We can put it right here, this distance. Okay, and we can run our line up to that. And we can get the edge of our cube right here. Just a little bit past where you would think it should be, right? That's right where it should be. Okay, well, let's make our cube and see if it really worked out for us. Okay, well, it looks right. Is it right? Well, if we look here, you know, that is pretty darn much the same, isn't it? Wow. And so, like I said, it gets a little bit crazy, when we're trying to really make measured cubes. What can I say? Just look for those relationships. All right.